In this video, we want to look at this problem from Cambridge checkpoint exercise. Alright, so it says that two squares and two equilateral triangles meet at a point. Okay, so here we assume that this is the first square, the first equilateral triangle, and this is the second. This is the first square and this is the second, and all of them meet at a point here. Okay, so and then the question says we should show that that equilateral triangle will fit into the gap here, which is this place. All right, so solution. What are you expected to do? This is a very simple problem. All right, for you to show that a triangle is equilateral. Meanwhile, let's complete the sketch of the triangle at that space there. Okay, so for you to show that a triangle is equilateral is to show that the three angles are equal. So that's one way of showing it, or you can show that the three sides are equal. Okay, so but in this case, we are not told specifically about the size of the sides. So but at least we can find the size of the angles. So it will be more useful for us to use the approach of the angles. So what are we expected to do? So watch here. From what we are given here, you can clearly see that the implication of what we have here is that this equilateral triangle has equal size with this square here, and that the same triangle 1 here has equal size with square 2. And the same thing happened here. Triangle 2 has equal size with square 1. And so by implication, all the shapes here have equal sides. Okay, so that means all these sides are all equal to each other from the observation. Okay, so what's the implication? So the implication on the triangle, meanwhile, like he said, is an equilateral triangle. So all the angles of these two triangles must be equal. So that means this angle here must be 60 degrees. Okay, and then also it must be 60 degrees also, including these two other sides, two other angles. And then for the squares, you know, of course, that a square is a rectangle and all the four angles of a rectangle are always equal. So apart from the fact that it's a square, so which means that all the angles should be equal. So here will be 90 degrees because the angles of a rectangle are always 90 degrees. And then here is also 90 degrees. Okay, so label the angle here. So we are looking for this angle. So if we find this angle, then we are expected to show that these other two angles are equal to it. Okay, that means all of them should be 60. All right, so now by implication, you know that we are told that angles at a point is 360 degrees. So that means if we add all the angles here at this point, remember they say they met at a point. Okay, so all of them should give us 360 degrees. So that means 60 degrees there. So we have 300 degrees plus x is equal to 360 degrees. Okay, so that means our x is equal to 360 minus 300, which is equal to 60 degrees. So we found one of the angles to be 60 degrees. So how do we get this other side? We are not told anything about these angles, but there is something we know. And what is that? That these two sides are equal. And if two sides of a triangle are equal, such triangles are called isosceles triangles, and the implication is that their base angles must also be equal. So these two base angles must be equal. Let us call them y. Okay, so that means if you add x plus the two y's, you are going to get the total sum of the angles of a triangle, which is 180 degrees. And so my x is 60 degrees, so I've already gotten x, and so y plus y will give us 2y, and so that's equal to 180 degrees. Okay, so from there we can quickly get that our 2y alone will be equal to 180 minus 60 degrees, which will give us 120 degrees. And so we are done. That means our y is equal to 120 degrees all over 2, and that is equal to 60 degrees. So we have found out that the three angles in that triangle are all 60 degrees each. So meaning that the triangle that will fit into this space here is going to be an equilateral triangle. That's all I said to show you in this video. Kindly subscribe to our channel, give a thumbs up to this video. We'll see you in our other contents. Bye.